Okay, so this becomes equation 4. Let's clean up this. What are we looking for? We're expected to differentiate y with respect to x here. So which will give us dy dx. When I say therefore, our dy dx will be equals to the product of the last two equations, and the last two equations are 4 and 3. That's equation iv and the ii. Their product becomes iv. We have dy du times I is du dx. Therefore, let's complete it here. Therefore, our dx, which is equals to, do we know, of course, our dy du is the whole of this, which is minus 1 over 2, then u to power minus 3 over 2 times du dx. Our du dx is said to be minus 2x. So we are going to have this to be minus 2x. So if we simplify further, that becomes that our dy dx will be equals to, when you, of course, you find out that we are going to have this to be, this minus here will make this minus to be positive. If that happens, we are going to have 2x u to power minus 3 over 2 all upon 2, such that these two will cancel that, left with dy dx to be equals to x u to power minus 3 over 2. Still recall from the law of indices. And of course, we are told that a to power minus n is something as 1 all upon a to power n. Having this in mind, let's apply it here. So we now have that our dy dx will be equals to x times, this becomes 1 over u to power 3 over 2. So we are going to have that dy dx will be equals to, of course this is over 1, x times 1 will give us x all upon 1 times u to power 3 over 2 will give us u to power 3 over 2. What is our u? Remember we said let u to be equal to 1 minus x squared. So we're going to substitute. So therefore, now say but our u is equal to 1 minus x squared. Therefore, we're going to have that our dy dx will be equals to x all upon, instead of u, we now have 1 minus x squared, all raised to power 3 over 2. So this is said to be the second derivative of y prime of y with respect to x. So this simply means that if we differentiate 1 over square root of 1 minus x squared, we are going to have x all upon 1 minus x squared, all in bracket, raised to power 3 over 2. Therefore, our y prime have to be x all upon square root of 1 minus x. Or, before we do that, 1 minus x squared all raised to power 3 over 2. So this becomes our equation 3. Remember, this is serving as our rough work. I'm going to clean. Okay. Remember we asked to show that 1 minus x squared y prime prime minus xy prime is equals to 0. If we turn this to be equation star, let's say equation star. So since we have gotten y prime, which is equation 2, and the y prime prime, which is equation 3, we can now substitute. Substituting for y prime prime and the y prime into equation star. So this is going to be, we have 1 minus x squared, 1 minus x squared, all multiplied, then y prime prime minus x y prime will be equals to 1 minus x squared times, do we know y prime prime? Yes, y prime prime is said to be this.